A team of scientists at the University of Vermont have invented a new tool, they call it a nanocage, that can catch and straighten out molecule-sized tangles of polymers. Once a knotty polymer strand, whether made of protein or plastic, is pulled open, then we can activate just the polymers we want, while leaving the rest alone, says UVM chemist Severin Schneebeli, who led the new research. This tool, that works a bit like pulling a wad of thread through a needle hole, opens a new way to create custom materials that have never been made before, he says. These might include nanoscale pill coatings that wrap around single molecules of medicine or new industrial products assembled from precisely arranged strands of plastic at the atomic scale. The tool, composed of molecular edges with special shape-directing hydrogen bonds, and thousands of times smaller than a pinhead, can select out shorter strands of a polymer, leaving longer ones behind, demonstrating that the nanocage can be used to selectively find particular sizes of molecule. It's selective and that's never been done before, Schneebeli says. This research is the first time that science has been able to distinguish and activate different size polymer chains in a lab, opening the door to new possibilities for precision chemistry. The new research was published in the June edition of the journal Chem. Nature knows the abilities of the nanocage are new to science, but not to nature. For billions of years, life has evolved ways to select just a bit of a protein or other biological knot that it wants to untie and turn on, what scientists call functionalize. But people have had a hard time doing the same thing. Despite plenty of examples in biology, the UVM scientists write, efficient and selective modification of human-made polymers is still difficult. Whether altering biological strands, like DNA, or industrial materials, like plastics, the new tetrahedron-shaped tool promises to let scientists do. It took years of hard work in the lab to assemble this tetrahedron before we could test it, says Mona Sharafi, the lead author on the new study, and postdoctoral researcher at the University of Vermont who came to the United States from Iran. It's entirely human-made, she says, but inspired by nature. Potent polymers. The word polymer comes from a pair of Greek words that mean many parts. And polymers are just that, materials made from huge molecules comprised of many repeating parts. They are found in many everyday products. Some are natural, like rubber and shellac. Many are synthetic, and are used to produce much of the material in everyday life, from shopping bags to diapers, clothing to water pipes. Polymers can be found in tidy long strings at the molecular level, or they can be tied up in godawful knots like a billion strands of micro-spaghetti. Nature has had eons to figure out how to both synthesize these huge molecules, biopolymers, like DNA, and how to edit and activate selected Po. People have gotten pretty good at making new synthetic polymers, but not so good at selecting and editing them. Many scientists and engineers, working on new applications for renewable energy e.g., next-generation solar cells, precision medicine like delivery of cancer drugs to targeted parts of the body, and advanced electronics including flexible devices, would like to have greater control and we have opened something big. Story source, materials provided by University of Vermont. Original written by Joshua E. Brown. Note, content may be edited for style and length. Thanks for watching. Do you like my video? Then show me your love by pressing like button. Please subscribe my channel and hit bell icon for new technology updates. Bye bye.